picked in a very beautiful question from NEET 2020. The question reads, a resistance wire connected in the left gap of a meter bridge balances a 10 ohm resistance in the right gap of a point which divides the bridge wire in the ratio 3:2. If the length of the resistance wire is 1.5 meter, then the length of the 1 ohm of the resistance wire is what? Okay, so I hope you are not getting that question, so only you have just watched this video now. So let's understand the question firstly. So firstly they are saying that there is a meter bridge. So usually you used to draw this meter bridge in this manner, isn't it? Somehow like this, and you will have this galvanometer. Okay, this will be connected in this manner, and you used to push that jockey here and there in this particular setup. So that is the meter bridge, and here you will have your resistance R, and this will be the unknown resistance, that is the X. So now just remind of the formula that you've studied for this meter bridge concept, that is unknown resistance is equal to this known resistance into 100 minus L by L. This was the formula. So this is all fine. Now let's read the question. Okay, so a resistance wire connected in the left gap of a meter bridge balances a 10 ohm resistance in the right gap. Okay, so a resistance wire connected in the left gap of a meter bridge. See, this is the plane. Okay, this is the plane. So this is the left side, this is the right side. Okay, so on the left gap of the meter bridge you can see that there is a resistance now. So this is the resistance wire, means the wire that is associated with the resistor. Okay, clear. Balances a 10 ohm resistor. You know that this is working on the principle of Wheatstone bridge. So this R divided by X, we used to take that for the derivation purpose. We used to take R divided by X as the ratio, and then we used to find this, and we will finally get this formula out there, isn't it? So this will balance this only. Okay, so that concept, if that was clear from the derivation and all, if you would have done, then this would have been easier. Okay, so also there is no issues now also you can remember this, that this R will balance this X. Okay, clear this point? Okay, fine. So now then if you see that balances a 10 ohm resistance in the right gap. So I said that this is the plane, so this is left. Okay, so this left resistance wire balances this right resistance wire, whose resistance is basically 10 ohm in the right gap at a point which divides the bridge wire in the ratio 3:2. So now this jockey divides into the ratio that is 3:2. So can't I write this as 3x and 2x? Obviously. So if it is 3:2 means you can write one length as 3x, other length as 2x basically. I hope this is clear. If the length of the resistance wire is 1.5 meter, that is this wire. So length of is equal to 1.5 meter, it is given in the question. Then the length of 1 ohm of resistance wire. So length of, we have to find the length of 1 ohm of resistance wire is equal to what? So now if you find the length of R resistance wire or length, if you are going to find it, so you're using unitary method, can't you find the resistance length of that 1 ohm wire? Obviously. So we have to find the R firstly, that is what you can get it from here. Okay, so now this X is equal to R into 100 minus L by L, right? So instead of this X they have itself given in the question, that is 10, and this is only unknown in this case. Okay, always the unknown should be unknown, it's not the fact, even this can be unknown. Now 100 minus L, so this is not 100 minus L in this case because this is 3x and 2x, they have given the ratio, so you can substitute that directly. Okay, so now X and X got cancelled, so it implies that R is equal to basically, so this is 100 minus L is this 2x, I am very sorry, and this is only 3, because you can see that very clearly. This was something that you would have assumed in your derivation, that it is your 100 minus L and this is your L, right? So this is this way. So this will be R is equal to 10 into 3 by 2. So this 2 5s are, so resistance you're getting 15 ohms basically. So now for 15 ohm wire, the resistance in the question, the resistance length is given 1.5 meter. So this is 1.5 meters. So 15 ohm tends to 15 by 10 meters I can write. So 1 ohm will tend to 15 by 10 into 15 meters. That is 1 by 10 meters, which is equal to 0.1 meters. So this is how you will do the question. I hope this was clear. I hope this was very clear. Thank you. Bye-bye.